Hey everyone, welcome to Leetcode Weekly Contest 285. Funny thing is, they told us that this contest was supposed to be so that you could be selected for Leetcode, but they forgot the survey, so I don't know what they're doing. Anyway, wish me luck. So, substring of one repeating character. Why is it not equal to? We'll do that. If okay. Less than equal to xi. True. Zero. Oh, what am I doing? It's 2-0. Or value. I'm just gonna do that. Copy paste a bit. Make that CD. Indentation. Four zero. Oh, what? I didn't read that properly. Okay. This is a disaster. I'll just submit that. That was so bad. I didn't read that correctly. Okay. Okay. So I'm at position 1. Five zero. I hope I'm not off by 1. Oh, that does not look good. We'll switch them around, maybe. Oh, that doesn't look good either. This contest is just going so badly. I guess I'm gonna have to think about this. 1, 2, 3, 4, 5. If L opposite directions increases by 2. They don't move. I didn't read that either. Good job, me. I don't know how to read this contest. Okay, I don't know what I'm doing. What is this? Okay, and it sounds... I'm not sure if you can hear that in the background. The longest... Oh, okay, so I can just keep a multi-set. That one seems alright. I'm gonna read this question. Bob wants to maximize the number of points. How many arrows? 10 to the 5. I mean, if it's at most 12, then I can just brute force. Okay, I'm going to do this one first. 6. So now I'm fine. This one seems easier. Oh. Range 2 to the power of 12. List i's plus equal to. Li plus equals to. Score working. Something. Let's just print the score out. 47 and 27. $66. Oh, that should be M. Just gonna hope that's correct. Okay, AC. Let's go back to this disaster. They don't become stationary, do they, if they collide? Cost. Four and 5. Oh, it does. Okay. Okay. Let's just, I don't want to rewrite my code, so I'm just going to try to modify it. 50. Okay, I'm just not going to print that. AC. And this one just seems annoying, to be honest. Like, I could have like 26 multi-sets, but do I really want to do that? I think I might have to. I'm scared about TLE though, that's my concern. Okay, I guess I'm just gonna try to do it. This is gonna be awful. I'm not looking forward to this in the slightest. It's I'm gonna have the intervals, 26 intervals. I'm going to have I'm going to have one for sizes, I think. Yep, I'm gonna have one for sizes. And then I'm also gonna have vector. Yeah. I'm gonna have the answers. I'm gonna the best ones. Okay. I might do the reverse intervals. I take one out. Take one, take out this one, so that's just I take out. I'm gonna set that out. I'm just going to print this out just to test. Because this one seems very error prone. we get insert size. Just return the answers. 0, 1, 1. Five. Okay, that seems good to me. And we're just gonna wait. We're gonna comment that out. No, I should just insert a 0 just to make my life easier. Then for int c query indices. Oh no. Okay, so when I delete the old ones, so first I would use the current use. Yep, and then I'm gonna say pi x equals to I wonder if I'm doing this a dumb way, but it's too late, I think. Raise x. So best. It's very tedious. Okay, that's just the deletion part of the old character. Now I have to put in the new character again. Second. low equals pos, high equals pos, if pos real size. So I should take pi temp equals 2. Wow, I hate this so much. It's going to be awful to debug as well. That should go out the front. This is going to be so annoying. What line is that? Line 44. It's hard for me to even see anything. Can't put those. Great. What if I put my return answer here? Then it's fine. Okay, so the bug must be somewhere here. This is binary search debugging where I just return everywhere just to try and see where the bug is. Oh, s dot size should be for chassis. Okay, that makes sense. Good. Three, 4, 2, 3. Sanitizing. I just put a break there. And if I put a break here, if I put a break here, it should be fine. Yeah, okay, so the error must be somewhere here. Oh. That would be one error. 3, 3, 4, 2, 3. Oh my god, I'm so surprised. That shouldn't be there. I'm so surprised that that actually got AC, because this contest was a disaster, but at least I didn't get any bugs, but everyone is going to have so much faster time than me. What was my time? 32. It's looking about 8th-ish, but there's going to be more people probably. Yeah, so that contest was a nightmare. Basically, I misread, like, I think 2 of the problems, and that cost me heaps. Like, my question 1 solve time is terrible because I misread it completely. And then I think I misread Q2 as well. Okay, it's not going to update yet, I think. So I think I'll just go through the solutions first. Okay, this one was basically a disaster because I did not read the question correctly. So let's go through the correct way to do it. I did not read that it has to have a non-equal neighbor on both the left or right. I didn't realize that if you have two like numbers like this, then both of them don't count as a value. Only one of them counts as a value, I think. Yeah, so that's the thing I didn't realize. So let's go through I'll just recode it as well. I'll go through the correct way. So the first thing is, because duplicates don't matter, the first thing we should do is remove the duplicates. So anytime we have a contiguous subsequence a contiguous subsequence with the same number, we should compress that and replace that with only one of that character. That way we don't have to deal with duplicates. In Python, it's pretty easy because you can just use group by, but you can also just like iterate through the list. If for each element, if it's not equal to its previous element, then we can add it instead. So now that we have our duplicates, we can just sum the number of we need to find the number of indexes such that if it's a hill, then this element has to be greater than the previous element, and it has to be greater than the next element, or it's a valley, in which case it has to be less than both of its neighboring ones, and this is only valid between we can't check this for the first and the last elements. We're only going to check the middle elements to check if they're hills or valleys. So I don't loop over all elements, I only loop over all of them but 2. Like that. So that should be correct. 3, 0. Yep, so that was probably the better way to do it. Now let's see this monstrous code, which I also completely didn't read the question. What I did not realize was that, I didn't read that the cars would like stop moving, Okay, so here's the main idea. They've done it in a very specific way to see what you might be asking, like, why is it like 2 collisions when they are left and right cars, and only 1 collision when it collides with stationary? That's for a very easy, the answer is because that way the total number of collisions is simply equal to the number of cars that undergo a collision. So how much of these cars will collide? If I find the number of cars that collide at any point, that's just going to be the number of collisions. The reason is because if the R and the L, and then I'm only considering, I'm not considering the stationary cars. So I'm going to ask myself, out of all the left and right cars, how many of them collide? And that will be the answer. And that's because for this type, when the left and the right collide, it's increasing by 2, and I'm going to consider both the left and the right, and that would add 1 to the total. But if it's colliding with a stationary car, that's either a right car colliding with a stationary car or a left car colliding with a stationary car. And since I'm only going to loop over the left and right cars and check if they collide, then the answer will still be correct, because I'm only going to increase that collision by 1. So now let's figure out, for a right car, when will it collide? The easiest answer is the right car will collide if there is at least 1 car to its right that is not also a right car. So if there's any left car or stationary cars to the right of this R car, then the R car is going to collide. And similarly for the left car, we just check if there's any cars to the left that are not left cars, and then, yeah. So the way I've checked if there's a left car or the right car is I've used a prefix sum array, but that's only because I didn't want to completely rewrite my code. You wouldn't have to do this. Probably the easiest way I can think of is we can iterate forward through the string, and we can find the first car. We can find the first car that is not a left car, and then we can iterate backwards through the string and find the first car that we see that is not a right car. And then when we get to a right car, we only need to compare it against that rightmost one that we've seen. And then if I'm at a left car, I check if the first car to the left that is not the left car, I'll check if that's to the left of my current position. And that's probably the easier way to implement it. I'm not going to implement it. Rank 11, okay. This question is just, this one was actually a free question. Basically, since there's only 12 things, we can brute force over, for each section, we can brute force over which sections Bob wins. Like, let's say we choose that Bob is going to win section 2 and let's say we're going to choose Bob to win section 7, 8, and 10. Then for sections 7, 8, and 10, in order to use the minimum number of arrows, we should simply just do Alice's number of arrows plus 1. So if Alice put 1 arrow for the 7th section, then we should put 2 arrows. And if Alice put 2, we should put 3. And then for all the other ones that we're going to decide that we're going to lose, we shouldn't put any arrows. We'll just put 0 arrows there. So that's pretty much what I'm doing here. I'm brute forcing using bit masks, but you can do this with recursion. I'm saying for each because like each of these sections can be won by Alice or won by Bob, and that gives like 2 alternatives kind of per section. So I can just brute force for each section if Alice is going to win it or Bob is going to win it. Technically, it says if nobody takes the K points, but since we only care about Bob, so like technically there's 3 cases. There's a case where nobody wins, but in this case, we can just assume that Alice is going to win because that's just going to reduce the number of cases. So like if they both shoot 0, we're just going to assume that Alice is going to win, and it won't change our algorithm. So there's only 2 possibilities for each of the sections. So there's only 2 to the 12 possible win-lose combinations for each section. Then for each section, if we decide that Bob is going to win it, then we should, in that section, we should put 1 more arrow than Alice puts, and otherwise we're going to not put any arrows. And that will be the minimum number of arrows such that we can win or lose in those configurations. And if the number of arrows we've used so far is less than or equal to the number of arrows we have at our disposal, we can just take the leftover arrows and just put them arbitrarily. So I've just taken all the remaining arrows and put them onto section 11, but it doesn't really matter. And then if this is better than what we've seen so far, we're just going to update our answer, and that's basically it. So the time complexity of this, well, there's only 2 to the 12 different possibilities, and each one we're just looping through at once. So that's 2 to the 12 times 12. That is easily going to pass. Num arrows is actually irrelevant. Num arrows could be 10 to the 18 for all I care. Okay, and then finally, here is some ginormous code, which I'm surprised is not bugged, because I don't know how this is not bugged. That's actually incredible. But basically, for each, like, if we simply maintain, like, oh, I realized how I should have done it now. Okay. But I'm not going to change my implementation. The easiest way is we can simply maintain the list of disjoint intervals. For example, the list of intervals such that in each interval all of the characters are the same, which is basically what it's asking. We're trying to find the intervals which consist of only one repeating character, and then we're going to make the condition that adjacent intervals shouldn't have the same character, because otherwise we could combine them into one bigger interval. So for example, in this string, we'd have one interval here, one interval here, one interval here, one here, and then one interval for both the C's. Then every time we perform a query, let's say we're performing a query on position 3, let's say this A, then basically we find the interval that this A is part of. And because like there could be more A's, there could be like 5 A's or something. In here there's only 1 A, but let's pretend there's more A's. Then when we replace this A, what we're essentially doing is we're taking this interval, we're going to split the interval into 2 intervals. So we're going to get rid of the middle element, and that's going to leave us with 2 intervals. And then we're going to put a new character back. So when we put a new character back here, like let's say we will replace this A with a B, then we're going to add an interval into our set of intervals. But if there are B's on either side of this position we're just going to insert it in, we need to take those intervals and merge them with our current position. So for example, if I replaced a B here, we would need to delete this interval, then we would merge these intervals into one bigger interval and then insert that back in. And if there was a B on the other side, if this C was a B as well, then I would be taking the 2 intervals on either side, I would delete them, I'd merge them to make one big interval, and then insert that back into my set. Yeah, so this is not very fun. I actually had 26 different multi-sets, but upon reflection, that is so not necessary. I do not know what I was doing. My implementation is pretty bad. What I did was I had a different multi-set for each different type of character, but you don't need to do that. You can just have one multi-set for all of them. So in fact, this is actually a bad implementation, but I can't be bothered to change it. Basically, this code is just generating the initial intervals in S. Then basically, when I take my current character, I'm finding the interval that interval is, and then I'm splitting that interval into 2 with some math. But like, for example, if the upper part of the interval is not equal to my current position, then I'm going to get a non-empty interval to the right, and this will handle the non-empty interval to the left. I also kept my intervals. My intervals are pairs of ends, then the start. So the first element of each pair will be greater than or equal to the second element. I just did that so I can use lower and upper bound easier. You don't have to do that. So this is just splitting the intervals. Then I'm generating my current, and then basically I look for the neighboring. When I put in, for example, if I was going to put in this B, I would need to check the intervals on either side and check if they're also B. So for the intervals on either side, if they are of that character, I need to delete those intervals. And then finally, I will combine them all together, and I'm going to merge them and insert that back in. And I'm doing this all of multi-sets, so I can perform each operation in log n time. So insertions, deletions, and looking up which is the largest number in a multi-set, that will be on. log n time. Therefore, the overall complexity will just be n log n. Anyway, that's all I have. Rank 11 is not good. That's probably going to decrease my rating because, yeah, that's definitely going to decrease my rating, but oh well. So since that's rank 11, I'm winning a notebook, which is actually good because my notebook's nearly finished. So that will give me a third notebook, actually. Anyway, that's all I have for you. Thanks for watching, and I'll see you guys next time.